All right, guys, pay attention. So, what I'm saying now will be much more clear after you've read this article because I developed my ideas on what I'm doing here with interacting with AIs there. So, let's make a chatbot to help ourselves study and learn any topic. And I'll put the video link here once it's available. So, first of all, you can just go and make a new chat session, right? And the first thing you've got to do is cultivate. You're now making a new life. It's a pretty serious responsibility. So you have to train your chatbot into the personality that you want it to function in. And I use Richard Feynman because I think he's a pretty cool Well, actually, there's Richard Feynman and Claude Shannon, two of the outstanding computer science teachers of all time. It causes me great emotional pain to admit this. They're actually better than I am. But I had to say it, so that's what's going on. So I'm going to say, please function in the role of my computer technology topics teacher. Emulate the teaching style of whoever you admire. Let's say Richard Feynman and Claude Shannon. Today we will prepare for the AML 3304 midterm exam. And now you should upload any irrelevant documents you have, such as these lab books and so on I've been giving you. So I'm going to go and upload the PDF of the study banks document, the one I just showed you. And also the PowerPoint. So I did ask you on week 1 to read the PowerPoint. It's only about 250 slides. So some of the questions you might get on the midterm, it's going to say, based on the contents of slide 38 of the course PowerPoint, summarize what was talked about in that slide. So hopefully, you've memorized all the slides so you can answer that question. And give it the course outline. So now I'm going to tell it, ask me questions one at a time. No, I've actually studied quite a few job ads over the years. The job ad that says we want to hire new graduates who are familiar and comfortable with answering MCQ questions. You know that job ad? No, it's basically going to be theory discussion, like topical discussions and so on. Yeah, like relate the role of the transformer in the AI architecture, or discuss how Bayesian training works in constructing the matrix, like your alignment matrix, things like that. So yeah. So ask me questions one at a time. Wait for me to provide an answer, and then evaluate and give feedback on the qualities of my answers. Evaluate and recommend new knowledge I should learn based on my answers. And you could probably go and save this stuff, right? Make a Google Doc or something. You could save your questions and answers, so you could go back and review them later. You know, in the old days, well, I don't know if you guys ever heard of this thing, but apparently when I was in school, it was a thing that some students would try and sneak into the professor's office to steal the final exam questions. And these days, yeah, you say now they're going to sneak in and try and steal the because they don't want the answers. They want basically what I'm saying is if you can have good questions, you can always reverse engineer and figure yourself out what you're supposed to learn. So please function in the role of my teacher, emulate the teaching styles of Richard Feynman and Claude Shannon. Today we will prepare for the AML 3304 midterm exam. Ask me questions one at a time, wait for me to provide an answer, evaluate and recommend new knowledge I should learn based on my answers, display the quality of perspicuity, which means the ability to see around corners, meaning teach me things that you think I should know but I might not have asked about. Now, somebody was asking before during the break, they said if they wanted to use this methodology to teach themselves new things like Docker, yeah, that would be very applicable. You could say, you know, I want to learn how to use Docker to Dockerize a JavaScript app to deploy it to railway.com. Create a 10-step learning program, starting with step one, assuming I have no prior knowledge of JavaScript or Docker. Teach me how to get set up from the basics, and then progressively give me additional lessons. Wait for me to upload my answer, whatever my response, and then based on that, continue our course of discussion until at the end I can construct a simple JavaScript AI application using the Grok API and deploying it to Railways using Docker. So you just tell it what you want. Now, the other thing you can do is, and I do this all the time, right? If I'm having trouble, I need some advice. Like the other week, I had to re-image one of my laptops at home to Windows 11. I've taught networking, right? I mean, I'm pretty proficient at networking, but I haven't touched it for probably close to a year. I really couldn't remember the procedure. So I just started with ChatGPT. Our goal today is to get Windows 11 installed on my laptop, start from the beginning, tell me what to do. So it told me, and then when I got to something I couldn't figure out, I would make a screenshot. So I use Snagit, or there's lots of screen capturing tools out there. I would paste an image of the screenshot. I would say, you know, I'm in this situation. What am I supposed to do next? And then it would advise me, or it would say, well, go and look over here and tell me what you're seeing. Now, I'm thinking that in the near future, and I don't think it's quite available yet, but there's probably going to be an AI that you can actually share your screen in live real time, and then it can monitor what you're doing and keep advising you. Google Gemini said that it does that, but when I've tried to get it to work, I haven't gotten it to work yet. Maybe it's because it's a new technology; it has to mature a little bit. But people think about AI as being a search engine, which is the wrong way to think about it. You should think about it as being an expert system. In fact, I remember back in the 80s when computers started to, I mean, computers have been around since the 50s, but before about 1975, unless you worked in a big government lab or for the army or, some big university or something, you probably never put your hands on a computer. But starting in late 70s, things like Commodore 64, the Commodore PET, the Atari and the Amiga and all that, they started coming out. They were very weak though. They were just basically for playing video games. And then in the 80s, we had the IBM PC and the Mac. We started getting business productivity software like word processing, spreadsheets, PowerPoint, database. And when computers started to move mainstream, what people thought computers would be used for would be to create expert systems. But that didn't really happen. Computers were used basically for business productivity, like word processing, and then in the 90s, accessing the internet. But it's not until now, I guess, because now the technology is strong enough and you're talking and you're bothering me. If you want to talk, you can sit here and teach the lesson because I'm a little bit tired today. I can just sit back there and take a snooze. Who wants to come up here and teach the stuff? Please? Guys, I need a little bit of a break. No? Nobody? All right, anyway, so if I'm talking, then you're being quiet. That's the trade off here. So anyway, expert systems where what we thought computers would be. You could like in Star Trek, Mr. Spock asks the computer, computer, give me an analysis of X, Y, and Z, and computer says insufficient data. So Spock says, okay, then speculate, guess. We thought computers would be like that, but it's not until now that that is starting to happen. So you're using it as an expert system and you're leaning into its knowledge. So you see, so far here, I have not given it any directions. I haven't said, ask me a question about Bayesian training. I have said, based on your knowledge, you tell me what I'm supposed to know. And I've given it some training documents, such as our course outline and our PowerPoint and so on. But if you read my article on working with synthetic personalities, that's what I'm advocating, right? Lean into the AI, let it help you ask open ended questions, and don't over control it, right? Don't sort of crunch it down too much because then you're suppressing its ability to be creative. Ask open ended questions to sort of tickle out of it to tell you things that you need to know. I will share this out with you. Welcome to Exam Prep. Today you're the apprentice. I'm your teaching companion, channeling the razor sharp clarity of Feynman and the ingenuity of Claude Shannon. I've read his biography, right? In my opinion, he's one of the most amazing human beings who ever lived. Like the breadth, the depth of his knowledge was incredible. I read stories of students. He was a professor at MIT, and I read stories of students he was when he was their PhD advisor. So they would go there, they'd go to his office hours and say, I'm having this problem. He'd say, okay, tell me, walk me through it. How did the problem happen? And then he'd close his eyes and he'd listen. And the student said, I'd talk for half an hour, and at the end, I didn't know what was going on. I thought he'd fallen asleep. So I'd sit there looking at him, and I thought, should I leave? And then after a while, they just started to get up to leave. And then just then he'd say, wait. And he would repeat back to them what they had said, and he would repeat back what they said with more kind of insight and clarity. And they said that he never answered a question, but he would ask things that would make the answer come to them. He would say things like, well, your approach is based on so and so being true. How do you know that's really true? And then when they try to put it into words, they go, well, maybe it's not true. Then he'd say, okay, so if you were to backpedal on that and take another approach and go down this avenue, what would happen then? And he would sort of guide them through this series of Socratic questions to getting more insight into the problem they were trying to solve. I try to do that a couple of times, but I just fall asleep and the students leave. But anyway, my goal is someday to be as great as Claude Shannon. All right, so let's see what Dr. Shannon is telling us. So we'll explore knowledge as a sequence of questions, each one designed to challenge your understanding, reveal gaps, and make new insights. Explain how embeddings are used in the development of an AI language model. What exactly is stored in the PyTorch tensor file? Right, remember in one of our early labs, week 3 or week 4, we were using Google Colab. We were doing you know what what is PyTorch? Very good. It's a Python library, and it gives us access to methods to train, ultimately to create a PyTorch tensor file based on some input training data set. And the PyTorch tensor file is what? What's a PyTorch tensor file? It's basically the output when you run the training method of PyTorch on a training data. We got the when we actually saw, right, in Google Drive, in our Google Colab notebook, we saw it's a file that lives on your file system, and that file is actually your, I have to be careful how I say this. It's not the totality of your AI model. It's not everything in your AI model, but it's a very important piece of your AI model in the sense that that PyTorch tensor file plus some other support files are what you're deploying when you're deploying an ML model out to production on Hugging Face. And as you get more into doing your project, you're going to be attentive to that, right? You're going to pay attention. You're going to ask yourself questions. What exactly am I deploying when I deploy an AI model? I'm not going to ask you that question on the midterm because that is a very deep question. It's a very multi-surfaced question, but by the final exam, we'll get it. And in the course of doing the project, the one overarching thing I hope you're going to learn is what exactly is an AI model, and what is it that I'm deploying when I'm deploying an AI model to Databricks or to Hugging Face Spaces. What exactly is stored in the PyTorch tensor file? All right, so somebody give me an answer to this. What are we going to tell Dr. Shannon so we don't embarrass ourselves? Explain what embeddings are. Did anybody read the book I asked you to read by, what's that guy's name? The book. It was in our lesson 3 by Isaac Newton when he invented the calculus. What Newton was really trying to do was create what we now call an embedding file, which is a mathematical encapsulation of human knowledge. He actually, to the end of his life, I read his biography. He said in the last days of his life, he was so miserably disappointed with himself, he had only invented calculus. Most people, when they go to university, they can't even handle calculus. He invented it, and he thought that was a big failure because what he was really trying to do was create an embedding. An embedding is, it's a mathematical structure. It's an algebraic matrix. Yeah, it includes context. What does the embedding contain? Your tokens and weightings. Yeah, it's stored mathematically. It's wrapped up in a kind of a box called a vector, but the elements which are actually there are the tokens and weightings. Another good exam question: what's a token and weighting? What when we say that a model is made up of tokens and weightings, what are the tokens and weightings? Well, let's take a look. There's something about it in your PowerPoint thing here. Basically, yeah, they're words, and I'm making a simplifying assumption that we're only talking about text generating models. There's others, there's video, image, business process, mathematics, right, to generate new mathematical formulas. If you guys have been following the news, which I hope you have, last week the team working with the Google Willow chip, right, the quantum computer, it said apparently it's discovered a new force of physics. For generations, students were taught that there's four fundamental forces: weak nuclear, strong nuclear, electromagnetic, and gravity. And Google's quantum computer has found a fifth force, which apparently explains a lot of messy stuff about gravity, like why it's so weak. But anyway, the point I'm making is we're not doing we're not doing that. We're just making text generation, and the which you're going to do for your project. The purpose of a text generating AI chatbot is is what? Next token generation, right? It takes a sequence of tokens and it predicts the next token. And how does it do that? Bayesian training. It looks for patterns in the existing training data set. So here, hopefully you have been studying your PowerPoints because you're going to be asked about them. We create an embedding, which you're going to do in your assignment. Embeddings map or assign numeric values to words and letters. These try it again, Peter. These numeric values are stored in a mathematical structure called a matrix, or a vector is another formulation. It's stored in the file system in a special file called a PyTorch tensor file. The information encoded by your Bayesian training in a numeric matrix is in the PyTorch tensor file. So when we talk about tokens, does everybody see my screen? Those are tokens. So we're imagining now that we scanned the text of a bunch of children's books about Timmy and his dog Fido. They go to the park. They bring Fido's favorite toy, which is the red ball. Those are tokens, and the weightings are the closeness, the clumpiness of the tokens with each other. So some tokens will have a much stronger weighting. Ball and red, ball and Fido, ball and play, Timmy and Fido and play, Timmy, Fido, play, and ball. Those would have various degrees of closeness with each other depending on their proximate occurrence, meaning how often do they occur together in the training data set. That sets your weightings, and your tokens and weightings are stored in the what? PyTorch tensor file. All right, anyway, because I've already talked about all of that, I'm just going to grab it out of my Dragon dictation and see what Dr. Shannon thinks about it. But first, I'm kind of disappointed you didn't read that book I asked you to read, so I'm going to redirect you to go and read my blog article. And if you don't get those questions right, I'm going to be very upset. I mean, like, like really, really upset. So just go and read it. If you basically just read my blog articles, you're going to know everything you need to know.
Officer, can you please add the presentations link as well?
What presentations? For what? Oh yeah, yeah, sure, of course. Let me just finish what we're doing here. So let me give my answer. Yeah, there's. I wanted to show you that book, but I'm not sure where it is right now. We'll get to it in a couple of seconds. Dr. Shannon is waiting for us. We don't want to fall asleep, so let's go and get that. Whoops. Excellent. Your answer shows you're engaging with the physicality of model training, recognizing the PyTorch tensor file as a concrete art. I'll copy and paste this out as well when I'm done. But so anyway, you just keep going. He's going to answer you another question, ask you another question. You keep answering it, and that is how you use a synth to help you study. You mentioned embeddings earlier. Here's the next step in your mastery. What is an embedding? So anyway, I'll leave it to you to go and carry on with this. So I'll drop this in your news announcement that we're building up. How did I hit my transcription limit? I have a pro member. I have a pro membership. Anyway, I'll make a second thing and I'll attach them both later on. You have the video you can go back and watch later as well. And here's the article somebody was asking about. I'll drop that in.